Question 11. Norman invested an amount of money for 3 years at an interest rate of 9% per annum, compounded monthly. At the end of this period, the value of his investment was $21,592.65. What was the amount to the nearest dollar that he invested? The first thing when you read a question about finance or financial mathematics and you see the word compounded, write down this formula. It's likely that you are going to need it. This formula says future value equals present value times by 1 plus the interest rate to the power of n, which is the amount of time that your investment has been invested for. You might be familiar with this in the format A equals P times 1 plus R to the power of n. This is the same formula. This says the amount that you have at the end of your investment equals the principal that you have or how much you're investing, your principal, times 1 plus the interest rate to the power of n. We have n, it's listed in 3 years. We have an interest rate of 9% per annum. And at the end of this period, the value of this investment was $21,592. So carefully reading that at the end of this period, right? This means that this value that you have here is your future value, your A value. What was the amount to the nearest dollar that he invested? Could also be borrowed, but in this case, this is an investment question. He invested. We want to know what the present value is, what his principal is. That is our unknown. Let's start entering the information. We know that A, or the future value, is $21,592.65, and that is equal to something we don't know the value of, times by 1 plus the rate. Let's look at the rate. It's listed as 9% per annum. So as I said to you before, the word compounded is important, but also the word monthly. Right? So compounded leads us to remembering to use this formula. The monthly part is an indication that we need to do something with our n value and our r value. Right? So this is our n value and this is our r value. It tells us that our n value needs to be in months, and so does our r value. And our r value is listed as 9% per annum, but we want it as per month. To do that, we recognize that there are 12 months per year. We take our per annum of 9% and we divide that by 12. And our n, we times that by 12 to get 36 months. Now I'm going to enter in all the information that I know into my formula. So I've got my A equals P, 1 plus, and I'm just going to write 9% divided by 12, or you can change that to 0.09, converting your percentage to a decimal, to the power of 36. So I'm now going to put this value here that you see, right, this thing here, I'm going to use a different color so you can see it. I'm going to put this value into my calculator to work out what this is, remembering that this is P times whatever this number is. Now if I want to get P by itself, I'm going to need to divide this number that I'm going to calculate shortly by both sides. So divide this side by that number and also divide this side by that number. That gives me P by itself, which is the aim of what I'm trying to do, and will tell me what my value for P actually is. So let's plug that into our calculator. We're going to start by sorting this one out, right? So we're going to go 9%, which is 0.09. I'm going to divide that by 12 to get my value up here of 0.0075. You might have this on your calculator as 7.5 with a number written in scientific notation. We're going to add 1 to that, press equals in between each one, and then we're going to take that to the power of 36. And that gives us 1.3086. Now I'm not going to round that number. Okay, this is important. We're not going to round this number. We're just going to leave it as is. And what we're going to do is we're going to divide both sides by that number. And we're doing that so that I can get P all by itself. And then I'm left with what I've got on the left-hand side. To do with that on the calculator, we take our amount at the end and we're going to divide it by our answer, right? And it gives us 16,500, which is the value of A.